Okay, so good morning everyone. Let's get started. So let me briefly review the relation between pointer and array. So usually when we declare array int A10 like this, we in the memory space we reserve 10 spaces. Let's say that 10 spaces for the integer variable. Let's think about that space takes room 1, so memory address 1 from 1 to and up to 10. Okay? So, and each memory can be accessed by A0 or an A1 and A9 by this array. So A0's memory address is 1 and A1's memory address is 2 and A9's memory address is 10. But basically, when we think about the A itself, what is the meaning of A? This A basically represents the memory address of the whole memory, which is the starting point of this the array. That is 1. So that's why int A10, and if we declare integer array A and the pointer PA, we can write PA equal to A, because this A contains the memory address of the starting point of this array. So basically we can use the PA equal to A. Okay? Then let's think about the AI. AI is the ith value of the array, right? Or this is a value that is stored at address A plus I, because A represents the memory address. So then A plus 0 is for the the memory address of the A0, and A plus 1 is the memory address of A1. So which means A plus I represents the end of AI. That is the memory address of AI. So A plus I is equal to memory address of the ith value of this the memory array, which means asterisk of the A plus I that represent the value in the A plus I address, that is equal to AI. Alright? So that's the important relation between array and the pointers. Okay, so please practice this example. This example shows the use of the array index and the pointers. So here we declared the unsigned integer array A and the double array B. Double means this is representing the real numbers like a float, but double actually can represent the wider range of the values. So the double is the larger one, then float, then characters. Then we also declare the unsigned integer pointer variable PA, double pointer variable PB, and character pointer variable PC, like this. Then we add. Okay, so let's look at this array, this integer array. So at first we print out the value of A and the value of PA. So the A is from this integer array, then this PA is assigned to be A. So basically, the value of A and the value of PA, they are equal because they both represent the starting point of this array, A. And the others are the same. This B and PB, by putting PB equal to B, so B and PB has the same value, and the C and PC also have the same value. And they commonly represent the starting point of the array. Then in the A, we assign the values from 0 to from 10 to 14, right? Using this for loop. then we print out in this form. First, A%D, and this %D is, for this %D, we print out I to represent the index and equal to U. Then this U, this %U is for the value of AI. So we print out AI, then asterisk AI, then address of the AI, and A plus I. So AI is the value, and asterisk of A plus I, they are the value. So this one and this one, they should be the represent the same memory space. So they should print out the same value. That value should be 10, 10, 11, 11, then exactly the same value, because A0 and the asterisk A plus 0, they both indicate the same memory space, and by reading the same memory room, so definitely we're gonna print out the same number. So similarly, if we print out the AND A, so address of the A0, that is equal to A plus 0, and it is also equal to the starting point, right? Because the A0 is the first room in that array. So the memory address of that first room is the starting address of the whole array. So if we increase index, that memory address is also increased in the next room. Then we move it, then we increase the index, then the next room's address is printed. So the room memory address is increased in this case 4 by 4, right? And similarly, when you say A plus 0 and A plus 1, A plus 2, so importantly in the pointer operation, when we say A plus 1, that doesn't not necessarily means numerical additions. So here, compared to A plus 0 and A plus 1, there's they are different by 4. They are not different by 1. Because this plus 1 means, it doesn't means, it does not means, the numerical plus 1. It actually means the next room. What's the next room? So the plus 1 is the next room's address. You got it? So it doesn't not means the 1. So so A plus 2 is increased by 2 by 4 is the same by 4. But important thing is the address of the A2 should be equal to A plus 2, because A plus 2 represents the memory address of the third rooms. Okay, so everything is the same. So putting in the B case, B is declared by double. So the memory address of each rooms is increased by 4 by 8. So that's why the B plus 0 and B plus 1, B plus 2, if you compare them, they are increased by 4, by 8. How about in character? They are actually increased by 1. Okay? So when you say the plus something in the pointer, on the pointer, that does not necessarily means numerical addition. It means next room. So you can think of it in this way. Because in this stage you are not familiar with the street address, but in the US or maybe Europe, so you are using street address. So like the 700 University Avenue, something like that, right? So that's your the address system. It appears. Oh, okay. So, but in the U.S., so usually U.S. or some European country has street address. That is, there's a big street, and there's some numbers are assigned to that each buildings of that room. But some buildings have the larger space, but some buildings have a small space. So when it has a larger space, if it's each address is 100, next building's address is 110. because that building is large. However, that building, if it's a smaller one, then 100, 105, and 110. So they are increasing in that way. So it's similar in here. So if each room for this variable, if these variables takes a large place in the memory, they actually have increased by 4. But if they have a small space in the memory, then increment is just small. So the increment by the point addition can be different by the variable types. Okay, so please practice this example. Okay. 여러분 제가 마지막 했던 설명을 다시 설명드리면요. 그러니까 제일 중요한 점은 그러니까 한국말로 했을 때 actually access AI by this formula. It first check what's the starting point of the array, that is and A0. Then by add index, then checking what is in that memory space. So even though in the program we use simply AI, computer understands in this way. In this way, asterisk of starting point plus I. Okay, so this is what computer understands. What actually computer handling this array, even though we simply use AI. Okay, so it is the same for the two-dimensional array. Let's think about the A3, 4. This is the two-dimensional array. But in A3, 4, in the human, the human programmer consider this is a double array. So we consider it as a matrix form. So this is the represent. So we consider that the A3, 4 represent a matrix 3 by 4, right? So it has 3 rows and 4 columns. That's what human understand. However, in the computer, in the memory space is just it's a line. So there's no matrix. So it actually store this matrix in a consecutive form, like just an array, just a one-dimensional array. So in total, in A34, it needs 12 memory space. So it reserves 12 memory space in a row in this way. So then it think because this one can be considered the 3 by 4 matrix, which means we have 3 arrays. It's the 3 arrays of which size is 4. Am I right? So that's 3 array. That's of size of 4. This is the first array and second array and third first and second and third arrays. Then the machine just assigned memory space in a row. So the first from the memory from 1 to 4. This is the first row, and the memory space is the 5th to the 8th. That's for the second row, and the 9th to the 12th. That's for the third row. So basically, because they are in a row, actually when we say Aij, this one is accessed by memory starting point, the A00, starting point of A00 plus 4 times I plus J. So Aij is, so we are simply using Aij in order to access the value of this double array, two-dimensional array. However, computer actually understand this value using this the point operation. Okay, starting from the start point, from the starting point of the array, then by access by 4 times I plus j, then we're gonna pick somewhere here, right? So you got it? So this is how the memory computer actually access 2-dimensional array. So if it's a 3-dimensional array, it's the same. It's the same. So in the 3-dimensional array, so by the operating some let's say the ijk, then it multiply some value times I plus some value times j plus k. So they actually access this one in that way. Okay. So for example, okay. So let's think about in here. In here, okay. So let me see. Okay, so in this example, A4, what is the value of the A1, 2? What's the value of the A1, 2? So let's think about we actually store these values for this 2-dimensional array. Then what's the value in A1, 2 in here? What? 42. Right? 42 because this one is for the A0 and this one is for the A1 and here 1 means the second array and this one is the third value. So in the second array, third value is 42. So this is 42. However, this 42 can be accessed by A plus, it's not A plus, it should be. So A00. So A00 means the A00 is here definitely, and by putting n, this is the starting point of the whole array. So A00 plus A00 plus 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6. 6 is also 42, and this is definitely same as A00 plus 1 plus 4 plus 2. So am I right? So in this index, because each one is repeated by 4 because we actually declare here 4 and here, then in the index I and index here is 2. Okay, so this is how we actually represent. Okay, then the simple quiz. So here is simple quiz. Let's think about integer a L, let's say L M N. Then if we say I J K, how can represent the access this the 3-dimensional array? Okay, so let's think of we declare 3-dimensional array with L M N, large L M N. Then we want to access the point I J K. Then how it is represented? It should be represented by star A asterisk of the starting point. What's the starting point of this array? What's the starting memory address? So end of A000. plus. And what's the value we should add? Anyone can do that in order to access the ijk. Please come on. Come on. Please come to here. 이거 일단 써보세요. 타이핑해서. 네. large. Okay. It's very similar, but I'm sorry that it's not exactly true. Is there anyone who can correct this one? It's the 80% is right, but if it's 80% right in the computer machine, it's wrong actually. Is there anyone who can actually? So please think about it. It's the three-dimensional array. So then if you want to make it in a row, so how can you do that? Please, could you correct this one? Okay, so okay, the problem is because the ijk started from 0, so that is right. So for example, if ijk they are all 0, they should be the a000. But in this formula, it's not, because there's a plus 1. Okay, so let's think of the ijk is all 0. Then this one should be asterisk and a000, and everything here should be 0. If ijk are all 0, am I right? Yeah. So there should be no plus 1. So this part is not right. I'm sorry, but yeah, this part is not right. But please think about so please think there's a three-dimensional array. Then you want to put it in a row. Then what you need to do is first you need to put it in the two-dimensional. Okay, please come on. If you have it, okay, change it back. Actually, is it right? Come on. You are very close, but do you think it's n? Yeah. It's a simple mistake. Okay, great. So it should be m, right? So it should be I times n times m, because this I is for n, and one increase of the n means there is the n by n matrix is repeated. So whenever I increase, the index should be jumped to the m plus n times m by. So you got it? And the j, m should be multiplied, and just we add k. Let me see. Is it right? Yes, it is right. Okay. You got it? Why it is shown in this way? So 학생 아시겠어요? 왜 이렇게 되는지? 그러니까 이게 3차원이기 때문에, 그러니까 이걸 일렬로 쭉 늘어난다고 생각하시면은 아마 이해가 되실 거예요. 네. 오케이. Okay. But here's some confusing point and some important point is, some important point is this one. So if it's a one-dimensional array, you can use asterisk and the asterisk and the starting point plus I. So this one is equivalent to the asterisk of A plus I. It is true. However, in here, this one is not same with this one. It's not the same with this one because it's a little bit complicated to explain. So when we add something of the pointer, that is actually increased. So the actual increment is different by its the data type. In here, because this is a one-dimensional array, this age data type is pointer array, integer star pointer array. However, in here, because A is declared by two-dimensional array, actually this A's data type is something very weird one, which is int asterisk 4. So this one is a little bit difficult to understand, but definitely important thing is this is not the integer pointer. So if you add something, it does not add the certain amount and the same amount with this integer array. It actually adds something weird value. So if you represent it in this way, it is not equal to this one. So just keep in mind. So this one is not equal to this one. You can write in this way in order to represent Aij, but you cannot use this for the two-dimensional array. Okay, so that's a little bit confusing part. Okay, so to practice this one, so please practice this example for the two-dimensional array. Okay. Then we assign the values 1, 2, 3, 4, 11, 12, 13, 14, 12, 22, 23, and 24. So those in total 12 variables. Then here we also declare the integer pointer. Then PA is assigned as the starting address or memory address of the A00, which means this is the memory address of the very first room of this two-dimensional array. Then here, index is calculated by I times 4 plus j. Okay, so this is the index in when this two-dimensional array is stored in a row. So here, if we access A, so in a two-dimensional form, like using the ij and aij, so as you see the A00, A01, A02, they are all shown up as expected. And then if you look at their memory address by using this the end mark here, then their memory address is as expected. They are actually consecutively have the rooms, consecutive rooms in a row. So starting from something 12 and 16, 20, 24 up to 56, right? So similarly, if we access the same memory space with in this form, PA plus A index. This index is like this, and the index is so the A plus 0. So actually, this is not A, right? It should be end of A00, okay? But I simply represent here A, but this is not, shouldn't be A. So when you plus 0, plus 1, plus 2, blah, 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 we actually access the same values, and their memory address is the same, okay? Alright, so I think you can do this one easily. Alright, and we have a homework this week. So in this homework, we're gonna practice the sorting example using pointers. So this is the example, but please replace, because they are all in the so basically you need to replace this array like the fi or fj, something. Please replace this, the array or using the pointer form. So please, rewrite this program using pointer instead of array. Okay. So this is, just the simple one that sort values. So you're gonna get 5 real numbers. Then you're gonna print the sorted ones. So, but usually, as I mentioned, the show up to now, this one is implemented in using arrays. But now the array is fundamentally equivalent to the pointer. So I believe you can easily convert this one using pointer notations. Okay. So and the due date is as usual on this Sunday midnight. Okay. Got it. All right. So then this is the almost 10:15. Then we're gonna have the 15-minute break. Then let's see here again. And sorry. 자, 여러분, 근데 하기 전에, 수업하기 전에, 출석을 부를게요. 여러분들이 하도 9시에 오시는 걸 힘들어 하셔서, 중간에 보도록 하겠습니다, 중간에. Okay, so we are discussing about, the pointers, because pointer is important, so that I actually reviewed several times. Okay, so the pointer means address, so memory address. Because computers, so when you use a computer is never understand the variable names. So even though you declare int A and int B and assign 3 to A, computer never understands these variable names. Instead, when you declare A and B, computer actually assigned some memory space for A and B. And their memory space, each memory space has their own memory address. That is 1 and 2. So computer only knows memory address instead of memory variable itself. So when you say A equals 3, computer actually understands, please put value 3 to the address of 1. That is what computer think. So the pointer is the C variable that contains a memory address. That's actually pointer. So, and the pointer variables are declared with asterisk for any data type. So int star or float star or double star or character star or user-defined function struct data star. So int star means pointer of the integer variable. Float star means pointer of the float variable. That means when you declare the pointing variable, they have their own memory space and their address is represented by pointer of the float. It's similar for anything. So then how can you access the memory address of a variable? That can be accessed by this AND character. So int A and star PA. So then we can say PA is equal to AND A. That means PA stores memory address of A. That's what happened here. Then definitely if we want to access the real value, a certain memory address, then we use the asterisk. So asterisk PA means the value that's stored in the memory space of which address is PA. So in this way, so if we declare A and B, and each memory address is 1 and 2. Then if we also declare PA and PB, because PA and PB, they are also a variable in C, they also need a certain memory space. So PA is stored at memory address 100 and PB is stored at memory address 101. And in this way, if we assign A equal to 3, so here, in memory address 1, 3 is stored. Then we say PA is memory address of A. Memory address of A is 1, so for the PA in the memory address 100, this value 1 is stored. Similarly, by saying PB is equal to and B in the memory address 101, for PB, 2 is stored. Then when you say the star PA, so PA's value is 1, and star means what is in the memory address of 1. Then we go to here, that is 3. So from this statement, this printf, 3 is printed out. Similarly, asterisk PB equal to asterisk PA, when we say like that, we read value in the PA by this asterisk, then the value is 3. So asterisk PA, the value is 3. Then we store this 3 value to the asterisk PB. That means the memory space of which address is PB. That is B. So the B's value becomes 3. Okay. Then again, so as I said today, so the array is basically pointer. Pointer and array, they are the same thing. Definitely, pointer can be the larger concept, but when we use array, so the real machines never understand the array. They actually convert everything to the pointers. So simply, then in the pointer, when we say AI, that means the value that's stored at memory address A plus I. And that memory address is equal to memory address of the AI. That means when you say A plus I, that memory address is equal to the AI's memory address. So, and AI. Then if we try to read value in that memory address using this asterisk A plus I is equal to AI. Okay? So that's a relation between array and pointers. I hope, because I explained these concepts several times, so I believe there is no question about this one. Okay, so then let's see let's look at the little bit more about the pointer and the string. Okay. All right. Okay, so the string is an array. String is one type of array. So what's the difference between string and array? String is a character array basically. But what's the difference? What's the unique features of the string? What makes a difference between string and just a character array? 여러분 캐릭터 어레이와 스트링의 차이가 뭐죠? 네? 네. 그러니까 null이죠, null로 끝난다. Okay, so the unique features of the string is null character. Null character. For example, when we say character S20 is equal to my love, or my love. So when we say my love, this my love itself has 1, 2, M, Y, space, L, O, V, E, 1, 2, 3, 4, 5, 6, 7. This my love itself has 7 characters. So if we store this my love just using as the character array, it takes only 7 spaces because it has 7 characters. However, if we store it as a string, it takes 7 plus 1, 8 spaces because it should include last null character that indicate the end of the string. So let's think about character, we say, the character 20 is, and my love, definitely, because, this is a character array, right? So the string is the special character array that end with the null character, right? So that means the string is, the character array. Because it's a character array, this S can be represented by star PC. Star PC is, again, the character pointer. So we can say this character pointer PC is equal to S. Then let's think about, because this character array, it takes 20 rooms in the memory space. And let's think about the first room's address is 100. Then starting with the 100, 101, 102, blah, 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 blah. Character array is divided over this space, right? Then, in the first room, of which array address is 100, M is stored, a large M is stored. And the next room, small y is stored. And the next room, y space, and L, O, V, E. And the last, null character, backslash, okay, backslash 0 is stored, which is a null character is stored. Definitely, we can use the more space because they actually declare 20 space, but these are the random values. So because these are the array, so the first address can be accessed by just S or S plus 0. Maybe S plus 0 is more clear here. So, why it's like that? So, it is S plus 0. Oops. So, the first one can be accessed by S plus 0, and S plus 1, and S plus 2, S plus 3, S plus 4, and blah blah, until S plus 7. Okay? Okay? You got it? Alright. Here, the value of S is 100, right? Then it represents a string. Then S represents a string that starting from the memory address 100 and ended by a null character. So when we say S here, this A represents string that started from the memory address 100, then ended by this null character. That is my love. Sweet word, my love. Am I right? Okay. But let's think about. But when we say S plus 1, that is 101. Then it also represents a string started from 101 and ended by null character. That is why love. Why? Why love? Yes. 네, 사랑. The love is all you need is love. 네, all you need is love. Okay, so that's what happened actually. So when you actually print f, so usually we use. Okay, so let's see here. So in this situation, okay, so in here, if we use, let's say, printf, %s and s, what will be printed out? S is declared in like this. Then if we say printf, %s and s, my love gonna be printed out, right? That's what you have learned. But if we print out printf, same %s and s plus 1, plus 1 is the string that started from the 101, because s plus 1 is 101, then ended by null. So using this statement, while love is printed out. If s plus 3, what gonna be printed out? Just love, right? That's actually how the string is represented. Okay? Then how about this? Plus 4. How about that? How about the PC plus 4? PC is stored by S. PC plus 4 and the print out PC plus 4 with percent S. OVE. Because PC is equivalent to S. Because here we say PC is S. Then PC is represent 100 and PC plus 4 is here 4. Then PC plus 4 is the represent string. That starts from PC 104, then ended by null. So O. Okay. So this is how we can handle. So how the different relation between pointer and string and array. So let's do the more interesting stuff. Oops. Okay. Okay. So let's get back. Okay. So let's do a little bit more. How about this? S2. Let's say S1. What is this one? So if we say S1, what's the value of S1? Y, small y, right. But in this case, it is a character, it's not string, right? It's a character, just one character. It's not string. So because it's a character, we use SY. Okay? So then how about plus 3? How about the asterisk of S plus 3? How about the asterisk of S plus 3? So it represents the value at the at the address of S plus 3. Am I right? So what's the value? L, large L, character L. Right? So the S plus 3 is this one. So just the character L. Okay? Okay, you got it? Alright, so then let's do something interesting one. Okay, here, if we make asterisk S plus 4 equal to null, we just assign the null character to this point. In this character, that means S plus 4 is 104, then 104's value become null character. Okay? Then if we use S, again, S is the string that's starting from the 100 up to null character, which is by this null, because it comes first. So in this case, S represents string my L, because this string is ended by here. So you got it? So if we change this S plus 4, so that this O with the null character, this string is ended here. And end here. So S represents my L. Then it's L. Okay? So the important thing is string is an array that ended by null character. That means a string is represented by a character pointer that indicates the head of the string, then it is ended by a null character. So if we insert null character in the middle, the string is something counted. Okay, so here is an example. So here is the example, and this example is, okay, we declare the S20 like the A, B, C, D, E, F, G, I, J, K, L, A, B, C, D, E, F, G, H, I, J, K, L. Then first, by repeating this I from 0 to string length of the S, we actually print out S plus I, then measure the length of S plus I. So initially when I is 0, so whole string is printed, but if I increase 1 by 1, so it moves to the next. So Si plus, let's say 7, represent F, G, H, I, J, K, L, and its string length is 7. No, it's 1, 2, 3, 0, 1, 2, 3, 4, 5. So S plus 5 is represent F, G, H, I, J, K, L, and its length is 7. Okay. Then if we string copy, so if we copy S plus 5 to the temp, S plus 5, this one F, J, I, J, K, L will be copied to the temp. Then if we print out temp, only this one is copied out. Then everything is the same. So then if we put in S0, S3, if we put the null, S gonna be only represented. So the 3 means 0, 1, 2, 3. In the position of D, if we put the null character, then it is because it is the S represent string ABC, and the S plus 4, 1, 2, 3, 4, it represents E, F, G, H, K, L. So this is how it's going. Okay, so please practice this one in order to get some idea about the use of string using pointers. Okay. Okay, so once you've done this example, please try to the examples. String parsing. String parsing is similar. So using the previous one, previous example, please do the string parsing. String parsing is we actually input a long string like 1 space 1 2 space 1 2 3 space 2 3 space 3 like this, or I love you, or all you need is love, something like that. So anything. Then you're gonna get those string using getS. So this in this you're gonna have a long string that's separated by space. Then parsing means we want to extract each word that separated by space. Then we want to store those words in the out. In this two-dimensional character array, or this is the string array that they can store with 2 strings. So if it's 1 2 3 1 2 3 2 3 3 is the inputted, then it has 6 words. 1 1 2 1 2 3 are 5 words. 2 3 and 3 separated by space. Then we want to parse this one. then put this 1 into the first out, and 1, 2 is the second out, and 1, 2, 3 is the third out, and blah blah blah. So then we print it out in this way. Out I to the n. This n is represented the number of words. Then we show you in total this number of words are inputted. So please fill this blank with your own by yourself. And first do this example, then please do this one. Okay? Practice this one, but it seems to be a little bit difficult for you guys at this moment. So I don't know, but actually it's not that difficult. So let me show you, how actually do this one. So there are so many ways to do that. But let's see here. Oops. Okay, it might be a little bit complicated, but it's fine. I think. Okay, so here first. Okay, so please see, please study this code very carefully. So this is actually a little bit it looks complicated, but it is very widely used style to handling the string data. Okay, let's start from here. Alright, so using getAs, we stored string in. So the 1 space 1 2 space 1 2 3 space 2 3 space 3, these are stored in. Okay. Then we declare character pointer ptr. Then we say ptr is equal 1, is in. So the ptr is actually starting point of this whole string. And here using this for loop. So we use this for loop. This for loop starts from the in, because we say ctr equal to in, and until that star cptr. Star cptr means, what's the star cptr means? cptr. Okay, so let's think about cptr is the pointers at certain point, and then asterisk cptr means character at that memory space. So if the cptr is equal to in, very first, star cptr is character 1. Then we repeat this for loop until this star cptr is not null. Okay? Then cptr is increased 1 by 1, by plus 1 at every loop. That means we started from the here, then move to next point, next point, next point, next point, next point, by plus plus until at the end of the string, because until this cptr is null. Okay, and at every step we test if the star cptr is equal to white space. So if it's not white space, it just moves to the next character. If it's not white space, if it's something alphabet, it moves to the next space. And if it is the white space, then what is this? Then we copy out n. So the n is initially 0. So out 0 means, so please record the double array. So out 0 is the, okay, so let me get back. So please represent, please remind the array, use of the double array. So when we say out character, out 32 128, so this is double array. So when we say out 0, it is the a character array of size 128. Am I right? Because the using just first first index, that is represent the whole row of this, the matrix, right? So out 0 means a character array of which size is 128. So it is a string. Out 0 can represent a string. So here, using string and copy, we copy PTR to the outend by size of CPTR minus PTR. Please think about it. What does it mean? So, okay, so what's the string and copy? String and copy. String and copy is copy string of the second argument to the first argument. The size, the copied size is given as a third argument. So this is the second argument. So what we say the source string is a whole PTR from here to here, because currently PTR is in from here to here. Then this size is given CPTR minus PTR. PTR is the starting point and CPTR is here, this point, because it's in space. So in this case, it's 1. So the only first part is copied to the end. Then in order to make it as a string, we put the null at the end of the string using this one. Then we increase the n, because we captured the first word. Then PTR is updated by CPTR plus 1. Current CPTR is pointing this space, and by plus 1, it actually indicates the next word, starting of the next word. Then we repeat it until we captured all of the words. And the last one, because and this is to handle the last one. Because the last one, there's nothing here, there's no space here. So in order to capture the last one, so we actually repeat the same thing once again. Then we have this one. Okay? So you got it? Okay, so please keep in mind this is the parsing code, because it can be used for the final exam or the other types of test. So please take, if I were you, so I would take a photo of this one. Please remember this code, please. 네. Okay, so if you have no questions, so we're gonna stop here. Okay, thank you very much today. So.